Okay, so part 2 of the properties of matter, section 2E notes, has to do with changes. We are going to look at physical changes, and then we are going to look at chemical changes. And again, if we are going to be talking about changes, we ought to define that. So, the definition of a change is making or becoming something different. All right? Making or becoming something different. So a physical change is a change in size or shape or state of matter, or one of those things that we've talked about previously with these notes. But the substance does not change its identity. If something undergoes a physical change, it does not change its identity. It's still the same stuff. And again, we can use those to separate heterogeneous mixtures and solutions if we wanted to. So, a physical change. If I get my hair cut, I've changed its size and possibly its shape overall. Okay, we've changed its length or whatever, but it's still hair. We didn't change its identity. If we mow the grass, if we take a piece of wood and we carve it into a totem pole, it's still wood. We have changed its size, shape, texture, whatever, but it's still the same thing. You know, we could take a piece of paper and we could crumple it. We could fold it. We could rip it or tear it. All of those things are going to change its size, shape, whatever, but it's still paper. Okay, that is a huge hint with physical changes. If you have the same substance that you started with at the end, then your change was a physical change. Okay? The second kind is called a chemical change. A chemical change is a change in one substance to another substance. The substance does change its identity. When it undergoes a chemical change, it becomes something new. Most of the time we call these chemical reactions, but what they are is a chemical change. Okay, so whenever what you start with is not what you end with, then that is a chemical change. Again, we can use those to separate mixtures if we wanted to. But again, because of our situation, we're not going to be doing too much of that. But I want to point that out again, that we could use that to do that. Okay, I'm going to have to use, there we go. So here are some important hints. Okay, anytime you see the production of, it produces, it makes, it creates, any of those words, then we are talking about a chemical change. We are creating something new. If you see a color change, that is a hint that a chemical reaction took place. Now let me just say for you that for every rule here, there are exceptions, okay? But generally, if you see a color change, that is indicative of a chemical change. However, we could take a piece of paper and take a blue marker and color it blue, and we've changed its color, but we didn't change the identity of what it was. It's still a piece of paper. So keep that in mind. With all of these, there are exceptions. If you see bubbles, if you see foam, if you see fizzing, those are important hints that there's probably a chemical reaction taking place. Now, again, in the videos that I'm going to have you watch, or that I would like you to watch, there's one with hydrochloric acid and I believe zinc. And there's tons and tons of bubbles being made. That is a chemical reaction. That hydrochloric acid is breaking down the zinc. Okay, it's making something new. It's not breaking down the zinc, but it's making a new substance in there. If there is an odor change, again, not that there is an odor, but that there is a change in the odor. That is when you have a hint that a chemical reaction has taken place or a chemical change has taken place. This one's kind of a silly example, but a good one, I think. Milk has a particular odor. I don't know that it's a good one or a bad one, but it does have an odor. If that milk goes sour, it now has a new odor that you wouldn't think is particularly pleasant, I would guess. That change in the odor tells us that a chemical reaction has taken place, a chemical change. The milk that you started with is not the milk that you end with. You have a whole new substance at the end. Okay, but the odor change was your hint. If it makes, creates, produces a sound, heat, light, those are all good hints that there was a chemical reaction taking place. Okay? One good example, I think the classic example of that is fireworks. If you hear the production of a sound, if we were close enough, you could feel the production of heat. There's a production of light. There's an odor change, and there's a color change. Okay, so those would all be good hints that there was a chemical reaction take place. And then the last one there is making a precipitate or a solid. A solid, this is, and there are some, one or two, I think, videos for you on that list of videos for you to look at. The one takes two clear liquids, and as soon as the clear liquid, a drop of it, touches the other clear liquid, you get a yellow substance, which first of all, there's a color change, a change in the color, and then it produces a solid. And if you watch those, they're puny little solids, but they're dense enough that they're falling to the bottom of the test tube. Okay, those are called precipitates. So those are all examples. I also want to just point out that weathering is a natural example of both chemical and physical changes. It could be erosion, something like that, where there's a physical change, but it doesn't change what the substance is. Just like dirt eroding from rain, a hard rain. It could be something physical, chemical, like acid rain, decomposing a statue or a monument or maybe even something like a cave structure or whatever. All right. Then the very last thing that we need to talk about here, because this is going to, all of these things are going to help us as we go into the next section, is the law of conservation of mass. Here's what it says. It says that the mass of all of the substances that are present before a chemical change has to equal the mass of all of the substances that remain after the chemical change. In other words, you can't create or destroy matter during a chemical change. You can rearrange the molecules and you can make something new, but you cannot make new matter or get rid of matter. Okay? You can't do that. The amount, the mass at this point in time, of the substances before the chemical change happened has to equal the mass of the substances afterwards. Okay, when we talk about, when we do section 3, the very last section, we will talk about balancing equations, and we will do that on a molecular level. Okay, you can't create or destroy level, but you can rearrange the molecules so that you can make something new. But the number of molecules before the reaction and the number after, not the molecules, but of the atoms, has to equal each other. All right? So I think that takes care of it. If you have any specific questions, you can message me, and I can address them for you. Thanks.